We're going to get the next session started. And I just want to introduce Philip James and Asheesh Laroia. They've both been developing in Python for over 10 years and both work at Stripe now, and they'll be uncovering the insights behind uWSGI for us. So let's go ahead and give them a round of applause.
Hello, welcome to Type uWSGI, press enter, what happens. If this is the talk you're looking for, hooray. If this isn't the talk you're looking for, feel free to leave, we won't be offended. So let's get started and say that you have written a web app. And you've written a web app in Django, you're ready to show it to the world, and you tell your friends about it, and they say, hey, you shouldn't just put that web app out there with run server, you should use this really cool technology called uWSGI. And you trust your friends, so you go, okay, what's this uWSGI thing? So you go to the uWSGI docs site, and you take a look at what it says, and it says things about application servers, and proxies, and process managers, and it seems really neat, but it doesn't exactly describe what uWSGI does, or what it's going to do for you, and why you should use it. And so that's what we're going to try to answer in this talk today. We're going to talk about how uWSGI handles processes from the operating system level, how uWSGI handles networking, again, looking at it from the operating system level. And then with that as the base, we're going to wrap up by talking about why we think you should, because it's why we use uWSGI. So who are we? My name is Philip James.
My name is Asheesh Laroia.
And in 2015, we gave a talk at PyCon US in Montreal, Canada, called Type Python, Press Enter, What Happens?, where we tried to answer the question, when you're at a terminal and you type Python and press Enter, what's actually going on at the operating system level when the prompt appears? And so we learned that there are these things on your operating system called processes, and that a common process that might be starting Python is a process called bash, and that the way that bash gets Python started for you is it makes a copy of itself, changes that copy to run the Python code, and then connects that to some file descriptors which you use to talk to Python and which Python uses to talk to you and the operating system. And so this is the model that we're going to be using to talk about how uWSGI operates with the operating system and connects to the world at large. And with that, I'm going to pass it to Asheesh to talk about processes.
Thanks, Philip. So to explain how uWSGI interacts with the operating system and creates processes, I'm going to use a sample web application called catserve. Catserve is an app that we wrote. It's pretty straightforward. You load the website, you get a picture of a cat, you hit reload, you get a new picture of a cat. You'd think this already existed on the internet, but nope, Philip and I had to write it. You can find a source code link here if you need to use our code yourself. What I'm going to show you now is that application running in development mode with a bit of a video. So if you're a visitor to the site, you might, this is in dev mode on localhost, but hopefully soon we'll be deploying this to the world. You visit the site, and you get a picture of a cat. And you hit reload, and you get a new picture of a cat. This is how we get happy users. We're trying to create a really good feedback loop. And I'd love to talk about that more, but instead I'm going to talk about processes, because that's what this section is about. So in order to get this application running, I typed out this command here. Hey, Philip.
Type uWSGI, press enter, what happens?
Thanks, Philip. So what happens is that it prints out a bunch of stuff here. Before I continue here, by the way, I want to actually do a quick show of hands. How many people here have used uWSGI, microWSGI, uWSGI, whatever it's called? Cool. Keep your hands up. How many of you have typed uWSGI on a console ever to start it? OK, actually more than I expected. Cool. Thanks. About half. When I have talked with other people about this, they often say, you can just type it. So yes, you can. And what you get is this printout here. I want to focus on this last line, where it says it spawned one uWSGI worker. What it's saying here is that it's created one process, which Philip alluded to before. A process is the operating system terminology for an instance of a running program. And it's also telling you the PID, or the process ID. And I want to illuminate that a bit more with some diagrams. So when we pressed enter, uWSGI got started, and it had a process ID of its own. It knew that it needed to start another process to actually run your Python application code. So it forked and executed the Python process here. Now, one thing you need to know about the uWSGI, aka uWSGI, protocol, which is true for Django and for Flask, it's true for uWSGI and for Gunicorn and for every uWSGI application server there is, uWSGI is a synchronous protocol. So that means that while your application is running inside the Python process, it can't do anything else. And I'll just illuminate that here with a spinner. When I loaded that homepage of catserve, the process did have to do a bit of work to compute in Python the string, the HTTP response to send back to the visitor. And doing that made this process unable to do anything else during that time. Thankfully, the homepage is pretty quick. Philip wrote it. It only takes about 50 milliseconds. What I want to tell you now about the part that I've been working on, the beta functionality of catserve. I've been personally branching out into machine learning, and I have figured out how to use tracking pixels left all over the web to indicate the best cats for each individual visitor. And to do that, it requires some complicated computations. I've been reading some papers, but I haven't been able to get the compute time down past 10 seconds, which is kind of slow. So I'm still working on it. That's why it's still in beta. But I want to show you what it looks like here. So you'll see it on the left. That Chrome is still spinning. You can see that in the top. Cats as a service. Unfortunately, it seems to slow down the page on the right. Only after the beta page loads does that formerly quick homepage load. So I think it's fair to say that by writing this beta feature in the app, I've ruined our service. Thankfully, I did figure out a command line trick that I can pass to uWSGI that unruins the service. And that is this -p2, which means run 2 worker processes. And you can see that when I press enter, uWSGI indicates that it has spawned 2 WSGI workers, WSGI worker 1 and WSGI worker 2, and they have 2 different process ID numbers. And to show you that that really did fix the problem, here's a video. I'm loading the beta page on the left, and even though it's still computing all of that complicated linear algebra, on the right side, the home page is loading lickety-split. And that can happen. Hopefully that's pretty clear now, that that's able to happen because there were 2 worker processes. But I'll show you that with a diagram to make sure that's extra clear. So uWSGI forked and executed, this time, 2 Python worker processes. And even though one of them was busy, executing my complicated beta logic, the second one was pretty available. It had nothing else to do. And so when a new request came in, it generated the HTTP response for that and handed it back to the visitor. And it can do that again and again, all while the first one is busy. So when I explained to Philip that this is mostly all there is to uWSGI, he asked me, how does uWSGI work with the operating system to pick which worker handles each request? And to explain that, Philip will come back.
Thanks, Asheesh. So now we're going to talk a little bit about how uWSGI handles networking. Specifically, what happens when you make a request against the server uWSGI is running on, and how does uWSGI and its workers handle that request? And so let's go back to our command output here. Specifically, let's look a bit more at this middle section, where it talks about something being HTTP bound on FD4, and you see there's another port auto-assigned to FD3. Now that FD is a hint from uWSGI about what's going on under the hood. If you remember from our process diagram at the beginning of the talk, we talked about processes having file descriptors, handles to things that behave like files that the process can use to communicate with the operating system, and that the operating system can use to communicate with the processes. By way of some example, let's pretend that we have a server you want to connect to, here indicated by a box. And there are some ports that you want to connect to for various services on the box. For this talk, we're using phone jacks to represent ports because that's a way you can think about them. You can think about them as numbered phone lines that get connected to by various services. One you might be familiar with is port 22. If you've connected to a remote server via SSH, you've used port 22. And so what SSH is doing is it's creating a socket, here represented by a phone, and plugging it into the port to make a connection. So when you connect to port 22, the SSHD process is listening on that port to the phone it's connected to the port, the socket, and answering the connections. We want to do something similar for uWSGI, where on port 8000, we want uWSGI to create a socket connected to the port so that it can handle connections that are coming in and respond to them. Now, it turns out that the sockets and the ports happen in a portion of the operating system called the kernel. The kernel is the core of the operating system. It's where all of the kind of heavy lifting happens in terms of interacting with hardware. And it turns out that when you're interacting with the network, you need to be interacting with hardware. And so there's the kernel, the part in purple, and then there's userland, which is where processes run, like SSHD and uWSGI. And userland communicates with the kernel through syscalls, commands that it can give to the kernel to say, hey, please do this for me. So let's dive into what's actually happening with uWSGI. Let's say you want to connect to your uWSGI server. You know you're going to be connecting on port 8000, and so you make a request to port 8000 from Chrome. However, right now uWSGI isn't connected to port 8000, so you get a connection refused. Nothing happens. So the first thing uWSGI needs to do in order to accept connections on that port is issue the socket syscall to create the socket that's going to connect to the port. Now, when it creates that socket, what's actually happening is uWSGI is getting back a file descriptor, a way of handling the socket so that it can listen to and read from connections. Now, we just have the socket right now, but we need to connect it to the port. And that happens through a syscall known as bind. Bind connects the port to the socket, and we're almost ready to start accepting connections, but we need to do one more thing. We need to tell the operating system, listen, hey, I have a socket and I have a port, they're connected, please start accepting connections. And so the kernel exposes that port and makes it available for listening, hence the port being kind of outside. Now this is the moment where uWSGI spawns its workers. You notice that they all have access to the same file descriptor, to the same socket, and that's because when a process calls fork and exec to make copies of itself, it keeps the file descriptors that it has from the initial startup. And so now there are 3 processes that all have a file descriptor for this socket. And when those processes, those worker processes start, they issue the syscall ePoll_wait, which is a way of telling the kernel, hey, we are ready and waiting for any connections that come in. So if you now try to make a connection from Chrome to your server, the operating system is going to notice the connection, and it's going to let the processes know, hey, there's an incoming connection. Both processes are going to try to pick up the phone. They're both going to call accept, which is how a process says, yes, I'm ready to accept this incoming connection. But there's only one connection, and they both can't win. It's like both people trying to pick up the phone at the same time. And so one process wins, and it gets a new socket for handling the response to the connection. The other process goes back to ePoll_waiting, and the process that won is now handling the response. And that's pretty much all there is to uWSGI handling networking. There are ports that get bound to sockets, and those sockets handle connections. And they are shared between the worker processes, which are always waiting until a new process comes in, and then calling accept when it's ready. With that foundation of how uWSGI handles processes and how uWSGI handles networking, we're going to now talk a bit about why you should use uWSGI, to talk about why we use uWSGI and why we think it's a pretty great thing. And I'll hand it back to Asheesh.
Thanks. So before I explain more about the rationale to use uWSGI, let me say that a lot of this rationale applies to any Python application server, for example, Gunicorn or CherryPy or ... Some of it is uWSGI specific, and you'll see that as it comes up. So the first, I think there are about 5 really good reasons to use uWSGI rather than the web application server that comes bundled with your web framework. For example, Django's managed Py run server. The first of those is graceful code reloading. So graceful code reloading is the goal that I should be able to change the code of my app and cause new requests to come in to a new version of that code without interrupting any requests that are being processed now, and without causing any downtime that's perceptible to people on the outside. And I'll show you how uWSGI does that by invoking some of those diagrams from before. So here we are. Here's an example diagram where uWSGI has these 2 Python worker processes. You can see that one of them is busy, spinning. You can see another one is ready, waiting, not handling any particular connection. So and you can also see that uWSGI still has this listen socket bound on number 4 that Philip told you about a moment ago. So when you tell uWSGI you want to switch to a new version of the code, what it does is sends the hang-up signal, aka sig-hup, to those two worker processes. Unix signals are a fascinating thing where the operating system interrupts whatever that process is supposed to be doing and jumps straight to the signal handler code. And uWSGI has installed a signal handler for sig-hup that says, if this program isn't handling a request right now, then just exit now. So the one on the right does that. If this worker is doing something, then mark itself as needs to exit, which I've done with this little power icon in the top right. So now that that remaining worker is marked that way, and the signal handler exits, it'll continue processing the request, calculating whatever page that was, and sending a response back to the client that connected. Eventually, it'll finish being busy, and it'll check, should I exit? It always checks if it should exit before it calls epoll wait that Philip alluded to before. And it should exit, so it does. Now, uWSGI has no more worker processes, and it's ready to re-execute itself. And you'll recall that the exec syscall that Philip talked about before keeps all of your file descriptors present. And so uWSGI basically erases its memory, and a new, fresh uWSGI process wakes up in that same process ID. The only thing that uWSGI new process has in common with the old one, other than the process ID number, is this listen socket. But that means that the socket never got closed. And so any inbound connections can still get queued up in the so-called listen queue. And so uWSGI, having just woken up, needs to start some workers. It does so. Those workers wake up, and they call accept. And that's how uWSGI can switch you to a new version of the code. There's one wrinkle in this story, which is that uWSGI, in this mode, does wait for all the worker processes to terminate. It only waits for at most 60 seconds, but that could be 60 seconds of people waiting with a little spinner in their Chrome, hoping for the web server to eventually respond. And if you'd like it to be even faster than that, uWSGI does have a mode where it restarts the workers one by one. It's just not the default mode. So there you go. This fancy code reloading stuff is something that Django Managed Pi run server cannot do. It will break a connection in the middle when it's time to reload the code, and it will create downtime visible to the external world by closing that socket you see here. So that's the first great reason to use uWSGI. The second one that's pretty important is tunability. By tunability, I mean making sure that uWSGI's resource usage fits your needs. So you'll remember this command that I ran to generate that diagram of 2 worker processes. But why 2? Why not 200? Why not 2 million? Just more worker processes. Handle all the requests you can. It'd be perfect. The only difficulty is your server will run out of RAM. Actually, there will be other difficulties too, but RAM will be the first difficulty. So in my calculations on my particular app that I was scaling up a few years ago, each Python worker took about 200 megabytes of RAM. So on a server with 2 gigabytes of RAM, maybe you could afford 10 of these processes, so you should put 10 there. Or maybe you should just leave it at 8 to be safe. Crucially, you should find out how much RAM your own workers take and do your own math. But the nice thing about uWSGI is it lets you change that number of processes to run very easily. So the next thing I want to talk about, sort of the third big reason to use uWSGI, is security. Security is a word that when people say it, everyone in the room suddenly feels inadequate. But I want to sort of dispel that a little bit by talking about some specific categories of security issues that web application servers can have to illustrate why the Django team says this about Managed Pi Run Server. This is a pretty vague yet scary warning. They say, Run Server has not gone through any security audits, and that's how it's going to stay. And when I read this, I kind of think, on one hand, maybe I know better than them. I mean, how hard could it really be to run a web application server? But on the other hand, I think maybe I should be suitably afraid if they don't plan to find out how bad it really is. I think it's probably not that bad, but I want to illustrate how security issues could arise for Run Server to give you some context about why they say that. By the way, the Django team will fix security issues and performance issues everywhere in the framework in general, just not in Run Server in particular. So I'm going to show you a text representation of an HTTP request for the homepage of catserve.io, which is not a service we run, sadly, but you could make this request here. This is a pretty straightforward text request if you've seen HTTP. If not, hopefully it's somewhat comprehensible. Somebody's getting the home page on catserve. But there's another way that we could have written that request, which is this here. I've added a second host header. What does that mean? I'm not really sure. And if run server has one idea of what it means, and something else in the stack has a different idea of what it means, then now that's a security problem. And in that sense, run server itself, or uWSGI itself, could be sort of free of security issues, but the interactions between the thing running your code and the rest of the stuff you're also running could create security issues. And that's the kind of thing where people are paying attention to those interactions with uWSGI. And so it seems like a safer bet to use something where people actually want to find out if it is secure and fix issues as they arise. So a fourth reason to use uWSGI is the fact that you can make config files. I don't need to go into this a whole lot, but I want to just illustrate that this command line here that I ran before with these parameters can be turned into this config file here. This text could be stored in a file. If you've maintained servers, you probably like config files. You might store them in Git. You might send them out to servers via Puppet. So if you like config files, great. uWSGI has that for you. But I want to conclude by talking about a whole lot of features that uWSGI has that I only learned about very recently. So for example, some people, including me, have used Nginx to serve static files so that you get a higher performance way to get static files out of your app without using up one of those Python workers that we saw before. Well, thankfully, uWSGI has built in a high-performance implementation in C of serving out static files. And if you need to limit how many requests get handled by any one worker until it gets terminated, maybe if you have a memory leak or if weird stuff just seems to happen after too many requests get handled by one worker process, cool, uWSGI's got an option for that. If you need to do delayed jobs in Python and you want a nice Python API for enqueuing tasks, dequeuing tasks, and running them slowly eventually outside of the main web application, then uWSGI has two different queuing systems you can use. If you want an application server that supports HTTPS or high-performance HTTP2, sure, great. If you want to kill workers when they take too long to do a request, you can enable the harakiri mode. If you want to find out which requests are slow, you can run uWSGI top. If you want to find out how much memory each request is taking, you can use memory report. If you're running Python 3.4 and you want to use async IO and coroutines to run stuff asynchronously, cool. uWSGI now has a beta feature for that. So if you already have uWSGI, it can do a lot. When I look at this list, I actually begin to think about what parts of my web app deployment I can remove. Maybe I can remove Nginx. Maybe I can remove Celery. Maybe I can remove Memcache. It also has a caching framework. So with those things said, I think I've left you with a bit of an answer to why use uWSGI. Fundamentally, it is because of the safe, graceful code reloading and the fact that you can tune it to the needs of your particular system. But there's a whole bunch of other stuff that it does too, if you already have it.
Hopefully now we have an answer to the questions of how uWSGI handles processes, how uWSGI handles networking, and why we think you should use uWSGI. Like we said before, notably those first two are pretty consistent across any Python web application server, like Unicorn or some of the mods that you can do with Nginx or Apache. But there are some very specific uWSGI things that we think make it worth at least exploring and maybe adding to your stack. And with that, we want to thank all of you for coming. We want to give a special thanks to Unbit himself, Roberto de Ioris, who went over this talk with us a bit, gave us some feedback, helped us understand exactly what uWSGI is doing under the hood. And we will, at this point, open it up for questions. If you want to ask us a question, please come to one of the microphones. And as Brandon said this morning, we would very much prefer it if your question was in the form of a question. But thank you very much. I think he was at the mic first, and then we'll round robin back and forth until we run out of questions, or run out of time, either way.
Excellent. Thank you for the talk. I wonder if you can tell us why it's the default way for all workers to exit instead of to replace them as they exit. Is there a trade-off we're not seeing here?
I can call accept on that.
Sure.
So, yeah. The question is about why uWSGI waits for all the workers to exit. And the reason is that, OK, I'm going to say this, and then it might not make sense. And so I guess I want you to shake your head if it didn't make sense. So uWSGI has by default, uWSGI attempts to conserve RAM usage by having one worker process import all your code, and then have that worker process use the fork syscall to make copies of itself. And that means that the import process in Python only happens once. That is to say, the compute time for it only happens once, and the results are copied to every worker process. In this mode, that means that if uWSGI operates in that mode, the only way uWSGI knows how to start n worker processes is by forking that first one. And so in that mode, it prefers to start itself fresh, start one fresh worker, and then have that one make copies of itself to fill in the space. So that's why it works that way. And there's a different mode that is now recommended where each worker does the import itself and therefore can get respawned individually when an older code version of the workers exits.
Any thought of just keeping one template worker around?
I mean, to keep one template worker around would mean forking copies of the older version of the web app. OK. Maybe we can talk more about it after this, but great.
Hey, thank you for the talk. I was just wondering if you could say more about uWSGI's caching feature. That was interesting. I didn't know anything about that.
Yeah, I think it was added recently because uWSGI added some like multi-mega scale stuff that needed a TCP cache framework and beyond. I mean, like a TCP accessible cache protocol. And I don't know about it much more beyond that, but the docs do.
Are there adapters for popular web frameworks? For example, Django?
That's a great question.
Thank you.
I don't know.
I'll add a quick note there that when I was looking at this talk and looking at doing a different talk a year ago about uWSGI and some other technologies, it's kind of mind-blowing that uWSGI ships with what more or less equates to a celery replacement. Like, there's a theory that goes that you have to run celery with your web app if you're trying to do large distributed tasks. Turns out that's maybe not true, and you should take a look at it. Anyways, question.
Yeah, great talk. Thanks. Question, for the incoming file descriptor being shared across n processes, is there a limit to how many processes that can efficiently scale to? Or is there ever a use case to invoke more than one uWSGI on a server to serve a single app?
You totally can have more than one uWSGI kind of master running with processes on a single app. I think I don't know if they would share the same port at that point. I believe you would want to have them be different ports because of that issue that you're talking about. In terms of what is the number, I don't know it. Maybe Asheesh knows it.
I'll add one more thing to that, which is there isn't a strict number, but uWSGI has a feature called the Thunder Lock. And the Thunder Lock is about how to have all those workers not all wake up at the same time to call accept, and rather for only one of them to wake up per request.
Right.
It comes with a little bit of runtime cost in exchange for having less so-called thundering herd problem. And there is an amazing article in the uWSGI docs about Thunderlock, which is the best way, I think, to avoid that problem.
OK, thank you very much.
And that ties into what we said about tunability. If you think, boy, I wish there was a way to make uWSGI do X, there probably is a way to make uWSGI do X. The options are far larger than anyone I think could cover in one talk. But question?
Hey there, thanks for the talk. I'm wondering, how do you know which file descriptors to close when you get a sick hop and which ones you don't want to close, like log files?
That is a great question. So it's worth noticing that those workers that we talked about are going to end. They are going to close. And uWSGI is going to spawn new workers when you do a code reload. So my guess would be that if you have specific log workers, or log files, those would probably reopen on startup because you have some logging line you're calling out to logging.getLogger and then log.info. And Python is going to reopen those log files when those workers start up again.
Thanks.
Sure. One last question, not over there. So you win. Last question.
All right. Thanks for the talk. Question about the HTTP2 support. Is that something that you can just, drop in your existing WSGI application and it'll just work? Or do you basically have to restructure your application to actually get any benefits from HTTP2?
I'm happy to do that if you want.
Yeah, I have an
Yeah.
inkling. I think you have a clear idea.
OK, well, so to answer what is a subset of your question, uWSGI has an option, I think --HTTP2-port, but something resembling that, where it will listen on HTTP2 and then do the same normal WSGI stuff internally. And so in that sense, you can begin getting these advantages automatically with no code changes. Having said that, HTTP2 gives you more connection reuse than HTTP2 did, and so there's probably another 20% of performance benefits that require thinking about your actual app.
And I should point out that we haven't, at least I haven't tested, I don't think you've tested, just like dropping that into, say, a running Django app. Will that work? Maybe. You should find out and come tell us. Because I know that some of the HTTP2 features are also maybe dependent on the code that you're running under uWSGI. So,
Thank you so very much.
thanks, everybody.
Thanks.
Thank you.
Application running in development mode with a bit of a video. So if you're a visitor to the site, you might, this is in dev mode on localhost, but hopefully soon we'll be deploying this to the world. You visit the site, and you get a picture of a cat. And you hit reload, and you get a new picture of a cat. This is how we get happy users. We're trying to create a really good feedback loop. And I'd love to talk about that more, but instead I'm going to talk about processes, because that's what this section is about. So in order to get this application running, I typed out this command here. Hey, Philip.
Type uWSGI, press enter, what happens?
Thanks, Philip. So
App out there with run server, you should use this really cool technology called uWSGI. And you trust your friends, so you go, OK, what's this uWSGI thing? So you go to the uWSGI docs site, and you take a look at what it says. And it says things about application servers and proxies and process managers. And it seems really neat, but it doesn't exactly describe what uWSGI does or what it's going to do for you and why you should use it. And so that's what we're going to try to answer in this talk today. We're going to talk about how uWSGI handles processes from the operating system level, how uWSGI handles networking, again, looking at it from the operating system level. And then with that as the base, we're going to wrap up by talking about why we think you should, because it's why we use uWSGI. So who are we? My name is Philip James. And so this is the model that we're going to be using to talk about how uWSGI operates with the operating system and connects to the world at large. And with that, I'm going to pass it to Asheesh to talk about processes.
thanks, Philip. So to explain how uWSGI interacts with the operating system and creates processes, I'm going to use a sample web application called catserve. Catserve is an app that we wrote. It's pretty straightforward. You load the website, you get a picture of a cat, you hit reload, you get a new picture of a cat. You'd think this already existed on the internet, but nope, Philip and I had to write it. You can find a source code link here if you need to use our code yourself. What I'm going to show you now is that application. My name is Asheesh Laroia.
And in 2015, we gave a talk at PyCon US in Montreal, Canada, called Type Python, Press Enter, What Happens?, where we tried to answer the question, when you're at a terminal and you type Python and press enter, what's actually going on at the operating system level when the prompt appears? And so we learned that there are these things on your operating system called processes, and that a common process that might be starting Python is a process called bash, and that the way that bash gets Python started for you is it makes a copy of itself, changes that copy to run the Python code, and then connects that to some file descriptors which you use to talk to Python and which Python uses to talk to you and the operating system.
We're going to get the next session started. And I just want to introduce Philip James and Asheesh Laroia. They've both been developing in Python for over 10 years and both work at Stripe now, and they'll be uncovering the insights behind uWSGI for us. So let's go ahead and give them a round of applause.
Hello, welcome to Type uWSGI, press enter what happens. If this is the talk you're looking for, hooray. If this isn't the talk you're looking for, feel free to leave, we won't be offended. So let's get started and say that you have written a web app. And you've written a web app in Django, you're ready to show it to the world, and you tell your friends about it, and they say, hey, you shouldn't just put that web